Okay. Good morning, everyone. Today we are going, I'm really feeling excited about this lecture. We are going to talk about determinants and their properties. In the previous sessions, we already started to deal with determinants. Either 2 by 2, معايا Miss Salma, or 3 by 3. We used determinants in order to solve a system of equation. In order to get an inverse, if you remember. I will review all of this. معايا حسين? Plus, we will have more information about the types of operations that will work with determinants, and also about some simple propositions that will help you out and make your life easier, a lot easier in dealing with determinants, step by step. Okay, let's start. Of course, everything, all the course resources, you will find them on Moodle, and also the recorded lectures. Please, about the recorded lectures, because I discovered sometime or previously that there is some students who are watching the videos as they uploaded on the general route of the channel. This is completely wrong. You will have to go to the playlist to choose your school mainly, and then go through the lectures. It's one by one. Some lectures are part 1, part 2, part 3 from each lecture, but they are ordered, well ordered. Don't study from on the general route of the channel, just to go to the playlists, okay? Choose the playlist of your school, either information management, SBE, whatever, okay? And start going through the videos. Don't watch the videos while you are eating, or don't watch the videos in the bus and doing nothing. You watch the video on your computer, you have a pen, you have a paper beside you, and please try to rewrite the propositions more than once, try to resolve the problems at least more than once. Then after you do this is like an activity. Try to solve your exercise, okay? It's really major to try to solve problems that you didn't see before. But before doing this, you will have to resolve the already solved examples. This is why we call them examples. Okay, are you with me? Okay, remember we are going to determinants. We just spoke about them. Determinant of a square matrix. What's a determinant? What's a matrix? What's the difference between a matrix and a determinant? A matrix is just an array, an arrangement of numbers. They are well arranged in rows and in columns. Each number or each entry of an array, it has its fixed row and column position. That's a matrix. The determinant is a real number. The determinant is a real number associated with a matrix. So it's something related to the matrix. That's a determinant. But it is a real number. It's just a number. So if you read the definition, I'm not going to read it and go through it, you can do this. In linear algebra, determinant, we usually have this symbol for a determinant. Is a value associated with a square matrix. So mainly, it's related to square matrices. That's the definition of a determinant. But then once more, a matrix, it's just the whole array. The identity by itself, the group of numbers that are arranged in rows and columns. The determinant, it's an associate value. It's a number, associate value to this matrix. But it's mainly dealing with matrices, square ones. Okay? Okay, very good. In order to get a determinant, very quickly, and I will go step by step. For a determinant 2 by 2, all of us know from our study in matrices that if this a matrix, I will write it this way. So, the matrix, I can say, the matrix A, which is, that's a bracket of a matrix. This is real, okay? So you can't change the brackets of a matrix and mix it with brackets of a determinant. That's a matrix. So the numbers are 5, 1, 4, and 2. This is a matrix. The dimension is simply, Mr. Hussein, is 2 by 2, which means 2 rows, 2 columns. The determinant of A, I can write it like this. I can write it as determinant of matrix A. Okay? Or simply determinant of A. They are all the same. In this case, once you see one of these symbols, it means I am getting the determinant that's associated to a matrix with this arrangement. How to evaluate it, Mr. Ziyad? I will multiply the elements of the principal diagonal, which is 5 times 2, then minus the elements on the secondary diagonal, which is 1 times 4. And it's gonna come up to just only 6. So the determinant of this matrix is just only 6. Okay, it's a number. I will need it down the road to use it somehow, and it is related to the matrix as you saw. Okay, that's for a 2 by 2. Okay, how to evaluate a determinant, Mr. Adham, for a matrix 1 by 1? Okay, so if I have a 1 by 1, Muhammad, like let's say B is equal to 5. That's a matrix 5. This is 1 row, 1 column. Okay, so the dimension is 1 by 1. So the determinants of B will be 5. Very simple. Okay? معايا Mr. Hussein? Okay, very good. Before I continue, let's finish the simplest forms of determinants, and we already did do that previously more than once. I will talk about a higher order, which is 3 by 3. Let's say 4, 2, 0, 1, 2, negative 1, 4, 3, and 2. That's a matrix A with dimension 3 rows in 3 columns. If I want to evaluate the value of the determinant associated to this matrix, or simply if I want to evaluate the determinant of this matrix, it's very simple. I can do it in plenty of ways. Mr. Hussein, you told me you don't remember how to do it using Sarah's rule. This rule, it is just only for a 3 by 3 determinants. All I have to do, remark that the principal diagonal, that's what's called the principal diagonal. Please look at the principal diagonal. Ziyad. You will remark that you have 3 numbers. It's acting like a triangle in the upper part. And also, there is another triangle on the lower part. It's really very simple. I will multiply the elements on the principal diagonal. What's the elements on the principal diagonal? It's gonna be 4 times 2 times 2, then plus. معايا Mr. Hussein? I have multiplied the elements on the principal diagonal, then plus. I will multiply the upper base of the upper triangle in the lower vertex. Okay? Or the vertex of the lower triangle. يبقى تاني once more. I will multiply the 2 numbers, okay, parallel to the diagonal, which are the base of the upper triangle, which is 2 times negative 1 times. These 2 numbers will be multiplied by this value, which is the vertex of the lower triangle. Just measure it. So it's gonna be 2 times negative 1 times 4. معايا زيادة؟ Plus. Exactly do the same. So I will multiply the base of the lower triangle and the head or in the vertex of the upper. So it's gonna be 1 times 3 times 0. Of course, if I'm evaluating this, I'm not gonna value or evaluate this part. Because this part it contains a 0, so simply it's going to be 0. I will do exactly the same adham, but on the other direction. Okay, that's the other direction. Step by step. That's the other direction, or the secondary diagonal. I will multiply, but I will add negative there. So it's going to be a negative 0 times 2 times 4. 0 times 2 times 4 minus. Same way like, please look at it. You have an upper triangle, you have a lower triangle. I will use the base of the upper triangle and the head of the lower one, and so on. So it's going to be 2 times 1 times 2, then minus. 2 times 1 times 2, then minus. Negative 1 times 3 times 4. Voila, the value of your determinant is already here. تفضل.
That's third rule.
Yes, yes of course. The determinant 2 by 2.
Determinant 3 by 3 هو third rule.
That just only for 3 by 3. Third rule. Okay? Just only for 3 by 3. تفضل يا عم.
هو انا عملت ده اللي هو 0 تايمز 2 تايمز
0 times 2
2
times 4. Okay, just a second. بص على ده كده. You will remark that I have an upper triangle and a lower triangle. عندي مثلث فوق ومثلث تحت.
نفس الحاجه بس
بضرب القاعدة اللي فوق، بص القاعدة اللي فوق في الراس اللي تحت. بعدين بضرب القاعدة اللي تحت في الراس اللي فوق. ملهم لي كده؟
بتبقى اللي هو 4 تايمز
لا، ابدأ بالقاعدة. 2 times 1 times بعدين بلس. Okay, there is a simpler way. Just. There is a simpler way for doing Sarah's rule, but it will cost you that you will write 2 columns once more. Okay? I will take the last 2 columns and I will put them here. And then I will go. So it's gonna be like 4, 1, 4, 2, 2, 3, 0, negative 1 and 2. Then I will take these 2 rows and put them back and write them once more. So it's gonna be 4, 1, 4, and then 2, 2, 3. I've repeated the first and the second columns. And I will go by the diagonal. I will go this direction, then 2 minus 1 times 4, then 0 times 1 times 3. That's for the positive parts, the first positive parts. Then I will do the same, but with the secondary. It will give you the same. It's Sarah's rule also. But I usually avoid this, because you will rewrite these 2 columns on the side. لا أنا بشتغل mainly على الكولمز، مش عايز أفتح بقى columns وروز ونقعد نلف ورا بعض. اوكي؟ بس أنا باخد عادة first and second column بنقلهم بعدين أفتحهم. اتفضل.
مش كان في طريقه ثانيه انا بكتب على الرو كولم بتاع 4 وبعدين احلها كده
لسه قدام. بس المهم الاول دلوقتي تشوف الصلص. ماشي؟ اتفضل يا فندم. اتفضل يا مستر عمر.
هو انا ممكن افضل احلها بالطريقه دي ولا هو ممكن يطلب اللي هو
لا هنا بيطلب منك انك تو ايفالويت بس. الغالبيه العظمى يعني for 90% it's gonna ask you about evaluating the determinant. It's up to you. In any method. What's really matter, Kareem, is this is the best rule for evaluating 3 by 3. معايا؟ مش جودي. If I have 4 by 4, it's not gonna work. If I have 5 by 5, it's not gonna work. Okay? So these rules are only applicable for 3 by 3. Dimensions more than this, it's not gonna be applicable. Okay? Or perfectly applied. أنا فاهم أنت هتقول إيه بس.
ايوه عايز احل باللي انا
حل باللي أنت عايزه.
ماشي.
المهم الفاليو.
ماشي.
Okay. Any questions in all of this? طبعا all of this we already did go through it previously more than once. حصل؟ حلو. Okay. يبقى this is for 2 by 2 once more. For a 3 by 3, this is Sarah's rule. And once more, I will explain it, Ya Omar. I will multiply the elements of the principal diagonal, which is simply 4 times 5, it's going to be 20. Times 10, it's going to be 200. That's the first three. Then plus 7 times 6 times 5, which is going to be 210. I can evaluate it by my mind. Then I will multiply negative 3 times 6 times 0. That's the first part. This is the first 3, second, and third. Then I will do exactly the same, but on the negative direction. So, Mr. Yusuf, I will go for 0, 4, and 5. Then I will go for 6 times 6 times 10. Then I will go for 7 times negative 3 times 5. As you can see, I have 6 parts in evaluating this value of a determinant 3 by 3. This is one of the famous methods to evaluate. There is another method to evaluate a 3 by 3 determinant, and it is applicable for any determinant which dimension greater than this, which is simply Laplace equation, or the Laplace formula for evaluating determinants. What's Laplace? We are going to evaluate what's called cofactors or algebraic complements. Both of these two meanings is applied. I will do it with you step by step. First of all, try to choose a row or a column. It's applied on rows and columns. So choose any row or any column. But before you do this, there is a sign rule. The sign rule for evaluating the cofactors or the algebraic complements, and once more, we already did go through this. Listen, Judy, I can start with positive, then negative, then positive, then negative. I'm moving as a zigzag. This is the sign rule if you just imagine it. Okay, I will start from here. Positive, negative, positive. Then I will go down. Negative, positive, negative. Then I will go down. Positive, negative, positive. There is no two positives after each other or two negatives following each other. It's working positive, negative, but you just move as a zigzag. The general rule is just only having a negative 1 to the power ya Salma of I plus j. So it will give you the sign. So once more, this is the element with first row, second column. Am I right? The sum of these two elements is 3, which is odd. So the sign will be negative. If I want to find the sign at this part, it's simply third row, second column. The sum of them is also odd. So the sign will be negative. If the sum of I and j is an even number, the sign is positive. If the sum of the I and j, the row number and the column numbers, if their summation is an odd number, so the sign will be negative. Very simple. Okay. I will choose any row, any column, but just put on your mind the sign rule. Let's do the first row, just only because it is written. Okay, I will start with 10. That's number 10, which is the element 1 and 1. Simply, Omar, eliminate the first row and the first column. Once you eliminate the first row and the first column, the rank or the dimension of this matrix will be less than by 1. You eliminated the row and column. So you will have a 3 by 3 matrix or a determinant associated to this matrix, which is 4, 6, 6, and 5. That's the first cofactor.
2 by 2.
Okay, which is 2 by 2. If I went to 7, okay, which is the second number on the first row, also, Ms. Judy, I will eliminate the first row and the second column. What are the numbers that will remain? Simply negative 3, 5, 6, and 5, which simply represent also a matrix 2 by 2. Here we go. This is 10, eliminate row and column, this is what you have. This is the determinant with a dimension less than the first by 1. Then I will do the sign rule. This number, sign rule is negative, so it's going to be negative. Of a 7, eliminate row and column. The remaining will be negative 3, 6, 5, and 5, as you can see. Finally, I will go to 0. Eliminating row and column, of course it's going to be 0, so I'm not going to evaluate it if I'm evaluating. I just want the rule to be in front of you. Okay, eliminating row and column, so you will have negative 3, 4, 5, and 6. Those are the determinants which is less than the main one that I'm evaluating by 1. But remark, for evaluating a 3 by 3 determinant, you will have 3 2 by 2 cofactors. That's what happens. This is 3 by 3. I ended up having how many cofactors? 3. All of them are less than this one by the dimension of the first matrix by 1. So if I have 4 by 4, first it's going to be a 4 3 by 3 determinants, and each one of these determinants will be a 3 2 by 2. So in order to find the value of a 4 by 4 determinant, you will have to deal with 6 determinants 2 by 2. Okay? So if I have to deal with a 5 determinants, you can do the math. You will be working with 5 determinants 4 by 4. Each one of them is 4 determinants 3 by 3. So it's going to come up to 20 3 by 3. If you expand a 3 by 3 to 3 2 by 2, you will be dealing with 60 cofactors. Each one of them is 2 by 2. This is why dealing with determinant Mr. Karim is not that easy to use unless you know the properties of matrices, which is going to make your life a lot easier. This lecture is dedicated for these properties. طب
هو ممكن يجيب لي 4 باي 4؟
اه
5 باي 5 برضه؟
وعادي
يا نهار ابيض.
دلوقتي عادي.
مش معايا طريقتين يعني.
لا عشان you will know the rest of the properties.
كمان؟
تمام؟ Let's go back step by step. So first of all, I'm very good in evaluating 2 by 2 and 3 by 3. It's done. خلاص, it's done. Okay. The transpose of a determinant. What's the transpose, Mr. Hussein? Okay. Replacing rows into columns and columns into rows. That's a transpose. One of the properties related to determinants, Ziyad, it's not going to affect the value. Okay? So, getting the transpose, replacing rows into columns. So if I have 10, 7, 0, that's the first row. It's going to simply be the first column, and so on. The second row, it will be the second column. And same way like the third row will be the third column. If you evaluate the value of the determinant of the main matrix and its transpose, they will be equal to each other. That's a very nice property. Another thing, if you have a complete row or a complete column equal to 0, the value of the determinant directly will be 0. Okay, once more. If I have, Ms. Judy, don't forget this. If I have a complete row or a complete column with zeros, then the value of this determinant will be, Mr. Ziyad, 0. You don't have to evaluate. Okay, very good. I will talk now about Kramer's method by the idea. All these slides, you already know about them. We already did do that previously. I will talk in specific about Kramer's rule, which is a rule for solving a system of equation based on determinants. It's one of the major methods that everyone is know about, which can solve easily a system of equations, okay, directly, but using or depending on determinants. The problem with Kramer has two problems. Ms. Judy, two problems. The first problem in Kramer's method, as you can see, it depends on determinants. So if I'm solving 4 by 4 or 5 by 5, it's not gonna be a very nice method to try. But for 2 by 2 or 3 by 3, it's nice to deal with. Okay, that's the first thing. The second thing, Mr. Yusuf, if I'm solving a system of equations, what are the possibilities? Do you remember? If I'm solving a system of equations, there are 3 possibilities. Do you remember them? If I'm solving a system of equations, the system, Mr. Karim, may be inconsistent, which means it has no solution. Or the system will be infinite number of solutions. Okay? Or there is a unique solution or just only one solution. Kramer solves just only unique solutions. For the other 2 methods, it's not applicable. It's not going to be able to evaluate. And the answer will be very quickly. تفضل.
هو في الامتحان يقول لي مثلا solve with grammar rule ولا
Maybe he will ask you to solve using Kramer, or he will ask you to use Gauss Jordan or Gauss elimination and so on. Okay? طبعا بص على Kramer. Let's see, Mr. Ziad. This is very nice. How to solve 2 equations in 2 unknowns using Kramer method, which is really very simple. All I have to do in order to solve a system of 2 by 2 equations is to write them first in a matrix form. So for the first system, which is a 2 by 2, that's a favorite system for Kramer. Can you write me the augmented matrix? Ziad, only the augmented matrix. 3,
1.
Okay, so you will go columns. 3 and 1.
No.
Huh?
1.
1 and 2.
5 and 4.
Then 5 and 4. Of course, you can write them as rows. And you can give it, I think you meant that, 3, 1 and 5 for the first equation. And for the second equation, 1, 2, 4, both of them is correct. That's the augmented matrix form. Okay? I can easily evaluate the following. This is a 2 by 2 system, so I will evaluate 3 determinants. Determinant number 1, determinant relative to the first variable, which is x1, and the determinant relative to x2. Okay, I will do that. First of all, give me the determinant of the coefficient matrix. Ziad Barber.
ماشي.
Huh?
1 times 2.
3, 1, 1, and 2. That's the determinant of the coefficient matrix. Then I will write the determinant which corresponds to the first variable, which is very simple. It's exactly the same determinant, but missing the first column. The first column, I will replace it with the result column, which is 5 and 4. Same way like you said, I will write the second determinant, which is relative to x2. It's very simple. I will start at the coefficient matrix, but I will replace the column for x2 by the results. So it's going to be 3 and 1. And those values, I will replace them by 5 and 4. Then start evaluating each one of them. I will start with the coefficient matrix, Ms. Judy. 3 times 2, it's going to be 6, minus 1, which equal to 5. That means it doesn't equal to 0. If the coefficient matrix is equal to 0, the determinant, it means Kramer rule can't be applied. This is number 1. Number 2, it means also that this system will never have one only solution. It will have either infinite number of solutions or no solution. So the first step to judge is to evaluate the determinant associated with the coefficient matrix. If it's not equal to 0, it means a lot of things. For the time being, you should know about them. First of all, since the determinant of the coefficient matrix doesn't equal to 0, the system has a unique solution. We can call it a Kramer system. The rank of this system is 2. Since the determinant of the coefficient matrix is not equal to 0. By the idea, the coefficient matrix will have an inverse. All of this related to the dimension or the determinant of the coefficient matrix doesn't equal to 0. معايا زياد? The second step, I will evaluate 5 times 2? 10. Minus 4, so the result simply is 6. Sensei, Mr. Karim. 3 times 4, which is 12. Minus 5, so the result will be 7. Any problems? The system is solved. X1 is gonna equal to delta X1 over delta. X2 is really very simple. Delta X2 over delta. You are done. The delta X1 is 6 over 5. And the other value is 7 over 5. You have solved the system. So, Cramer's method is one of the successful methods in dealing with or using determinants and solving systems of equations. But unfortunately, it has 2 disadvantages. The first of them, as it depends on the value of determinants, once the dimension grow bigger, the solution is not it's not going to be handleable. You can lower the EC. Okay? So this is number 1. Number 2, it solves only unique solutions, or just only one solution. Okay? Delta X1, 6 over 5. 7 over 5. This is for X1, that's for X2. اتفضل. خلاص؟ يعني كده تمام. طيب يعني كده تمام، مفيش أي مشاكل. اوكي بيرفكت. شباب، مستر زياد مبسوط؟ حلو؟ جميلة جدا، هي كمان بتحبك قوي. برضه now, get the values of the following determinants. This is the coefficient matrix. That's delta 1 and that's delta 2. دول الثري. على طول الحركة اللي بعديها. Get دلتا 1 مع الشباب. دلتا 1 over دلتا. معايا زياد معايا؟ ماشي الحال؟ طبعا جبت x2. تعالى let's do 3 by 3. نور، هو انا كنت بحل 2 by 2 system صح؟ System of 2 equations 2 unknowns. كده انا عملت evaluation ل how many determinants? 3 determinants. So the number of determinants usually exceed the dimension of the equations by 1. So solving 3 by 3, it means you will find or you will evaluate 4 determinants. Each one of them is a 3 by 3. Here we go. Look at this system of equations. You thought, once you look to this system of equations, please try in all times to be sure that it is well arranged. Is it well arranged? No. ليه بقى؟ لأن the second equation, it starts with x2 and should start with x1. So remember this arrangement. So first of all, I will try to rearrange them. I can write the systems directly. I will write them for you for the first one, and then we will go through the rest from the slides. Okay. I usually prefer to do the values or evaluate Cramer's like this. This is x1, which is gonna be, I will write the coefficient matrix in the denominator. So it's gonna be a 10 for the first column, then it's gonna be a -3, then it's gonna be a 5. For the second column, it's gonna start with -7, then +2, then -1. For the third column, it will start with a 0, then 6 and 5. I will write exactly the same determinant on the denominator, but just only with replacing the first column, which is the column of the coefficients of x1. So it's gonna be 7, 4, and 6. This is 7, then that's 4 and 6. While the other two columns will remain the same, which is gonna be a -7, 2, and the -1. Then I will have 0, 6, and 5. Now I can evaluate the value of x1. Based on the coefficient matrix shouldn't equal to 0. if the coefficient matrix determinant was equal to 0, it means you will never have a unique solution. You will have either no solution or infinite number of solutions. Do you read me? Of course, x2 will be exactly the same, Mr. Karim. The denominator will be the same. The denominator will be the same, which is gonna be which is going to be 10, negative 3 and 5, negative 7, 2 and the negative 1, 0, 6 and 5. For the denominator, I will replace the second column. So it's going to be 10, negative 3 and 5, and just replacing the coefficients relative to x2. معايا كريم? 0, 6 and 5. And instead of the second one, I will have a 7, 4, and 6. Now I will evaluate them. And so on. Okay, it's already done. That's the determinant is going to be negative 155. The value of the determinant on the denominator is going to be 0. So x1 is going to equal to 0. Okay, that's going to be delta 2, which is relative to the coefficient associated with the second determinant, this one, and the denominator is exactly the same, and it's coming to negative 1, and that's for x squared. I will do exactly the same, but just replacing the last column with the result one. Okay, this is the simplest way to see chromosomes. As you can see, to evaluate 3 by 3, I ended up dealing with 4 determinants, each one of them 3 by 3. Can you imagine if I have 4 by 4? How it's gonna be? A 4 by 4 system. You will have to evaluate 5, first of all, 5 determinants. Each one of them is 4 by 4. And each one of the 4 by 4 should be, by the cofactor method, it will be expanded into 4 3 by 3, and so on. So it's a huge number of determinants. That's the problem, the main problem, okay, of Kramer. اتفضل يا نور، بس تعالى بسرعة اتفضل.
هو ايه اللي كده اشوفه عارف ان انا ابدا احل الكلام؟
ايه؟
ايه اللي انا شفت المساله او
If you have 2 by 2 or 3 by 3, why not to use Kramer?
في
Okay?
دول قدام كده
I know.